So now we are going to discuss question number 50 and 51 for test series 7. They are common data questions, and this question belongs to the topic of transducers, more specifically resistive type of transducers. Fine. So there is a bridge circuit which is in front of you, and in the two arm, that is in the BC and CD arm, they have two resistors which are mounted on a cantilever, that is duralumin cantilever. So question number 50 goes as: two electrical resistance strain gauges are bonded to a duralumin cantilever and connected into a bridge circuit as shown in the figure above. Each gauge has a resistance of 100 ohm and a sensitivity f of 2.1, and m is equals to 1. M is one of the parameter which is given in the figure also. M VAC, that is the supply voltage, is 4 volt. If a force P is applied until the mean stress at the gauge is plus minus 200 meganewton per meter square, the modulus of elasticity E for duralumin is 70 giganewton per meter square. Then calculate the change of resistance in arm 3 to restore the balance in a null type bridge. Okay, so now if you see, the arm 3 is connected in the bottom side, that is the resistance is connected in the bottom side. So if you bend the cantilever from the top side, the P in your figure, you consider it on your figure, so P is given. So if you put a pressure at the point P where it is acting, then cantilever will bend. So the cantilever is bending, because of which the resistance which is placed on the back side, there are two resistance RA which is placed on the cantilever. One is the top side, which is the solid one, and the other one is hashed or dashed, that you can see at the back side, that is on the back side. That's the reason why they have marked it in the dash, like dash. So if the cantilever will bend from the top, then the strain gauge or the resistance which is mounted on the back side, it will get compression. So because of that, the resistance of that will always decrease. Fine, because it is on the back side, you are pressing cantilever from the top, so the resistance on the back side will get compression in that. Because of that, the resistance is going to decrease. So a reduction or decrease of resistance will happen in that case. So you have to check this from the figure where the pressure P is acting. So the resistance on the other side, it is on the top side, it will increase because it will experience tension, and the resistance on the back side will experience compression, so it will decrease. Fine. So now for finding out the magnitude, that what is the magnitude. Fine. So if you see question number 50, we are discussing it first. So using the equation, but here the factor of 2 will be used because it's a 2 active arms, because you are having the strain gauge connected in two arms, that is BC and CD. So two arms are connected with the strain gauges, so it is having two active arms. So I will just write down that using the equation below, but just use a factor of 2 as there are two active arms. So depending upon the active arms, you are going to use it. If in all the four arms they will connect strain gauges or resistances which varies, then you have to use 4. In this, only in two arms the active gauges are connected or the strain gauges are connected, so you are using the factor of 2. So use this equation, direct equation, delta R3 2, because two active gauges, epsilon F into R. Now all values are given to you, so which turns out to be F into R by E. E is the modulus of elasticity, resistance, sensitivity, sigma 2. Fine. So to just put the values, so 2 into 200 to 10 power 6 into 2.1 sensitivity into 100 divided by 70 giga is 10 power 9. So if you solve this, it will come to be 1.2 ohms. Now, but you have 1.2 ohms in A and B. A says decrease, B says increase. But as we have discussed that the gauge is experiencing compression. Because of compression, it is going to be decrease. Okay, so 1.2 ohm decrease. Fine. So if you see option number 50, question number 50, and option number A, which says 1.2 ohm with decreasing resistance, is very much correct.